Hi, my name is Josh, and this is my project on ecological design and its importance in sustainable solutions to engineering problems. I'm here at Westhills, one of Langford's largest and most ambitious ongoing community projects since 2006. This is actually where I went to high school, Belmont, and I have a lot of fond memories with friends here. During the summer, we would go to Langford Lake and go swim, paddleboard, stuff like that. And we had this after school routine where we'd go to the YMCA, go work out, and then head to Tim Hortons to go get some food. Now, among the 3,000 residents that currently live here, that routine is probably pretty common considering that Langford has some pretty big plans for this place. According to the Westhills master plan, which is publicly available by the city of Langford, about 517 acres of land will be dedicated to housing, schools, recreational centers, and trails. Another important detail on the master plan is their dedication to park spaces. Approximately 40% of the space being used for the Westhills expansion will be dedicated to forestry, fields like soccer fields, and possibly undisturbed natural habitats. Now, it's clear from the sound of it that the complete expansion of Westhills will probably take years, maybe even decades, so it brings up a lot of questions on how they're going to go through with the expansion considering the specifications of the master plan and the future problems that they'll probably face with the land. So out of all the subcategories of civil engineering, I chose to cover stormwater management since as the Westhills community grows, the combination of urban expansion and the complex terrain will negatively affect the nearby bodies of water, namely Glen Lake and Langford Lake, through increased runoff and higher likelihoods of erosion. As for the relevant earth system, the hydrosphere easily has the most connection to stormwater management, but there's also some natural connection to the geosphere and biosphere as well. Now, both Langford Lake and Glen Lake have a history of water quality issues, as I'll show on screen here. So it's important for us to frequently collect informative data so that we can help mitigate or even possibly prevent these issues from arising during the expansion of Westhills. Some of the data that will be collected is topographic data to see trends in surface elevations, soil infiltration rates for regional soil permeability, and precipitation data to account for how much rain actually goes into the watersheds. Now, the collection of data means nothing without a practical purpose, and since the Westhills expansion strongly emphasizes green solutions and coexistence with nature, ecological design plays a major role in further development. Ecological design, by definition, is an approach to design that emphasizes environmental impacts and long-term interactions with nature. In an engineering and stormwater management context, this includes designs that mimic natural hydrology, heavily considers nature, and are resilient enough in severe cases of storm. However, the ecological design of a real-world project such as Westhills is more complex than that, as it involves negotiations, community values, resource management trade-offs, and arguments surrounding what it means to be green. To succeed in ecological design, teams made up of water systems, geotechnical and environmental engineers, as well as GIS specialists, indigenous knowledge holders, and urban architects are necessary. Together, they encompass the necessary skills required to move forward. It's important to remind ourselves that the Westhills expansion is still an ongoing project, filled with teams of professionals who've already collected numerous important data, while using what they've learned to best work with nature as much as possible. With that being said, let's continue to keep an eye on the Westhills community and see what they have in store for us next.